Hello everyone, my name is Rishi Chakraborty. I am a master student at the University of Exeter. So I will be presenting a presentation which is a part of the assignment on learning from data. So let's begin. So my research question is, can we predict if a patient will have a stroke, will suffer from a stroke based on several factors such as weight, body mass index, age of the person, whether the person has hypertension or not. So one of the things to understand is traditionally it was thought that having hypertension is it's a great indicator of whether the person will suffer from a stroke or not. But often it's not as simple as that. There are other factors at play: age of the person, hypertension, how much active the person is, lifestyle of the person. So these things are often at play behind whether the person actually suffers a stroke or not. So I have attempted to make a machine learning model which will take in several factors, which studies a data set of several factors such as weight, body mass index, all these sorts of things, and actually make predictions on whether the person will suffer from a stroke or not. Now, this is a very important fact, I would say. This is because this can actually prevent strokes. On the other hand, if say my if say the model actually can prevent strokes in the sense that preventive medicines, if the model says classifies the person as being at risk of strokes, preventive medicines and even tests, further tests can definitely help people from avoiding the risk of having a stroke. Now, let's move on to the introduction of the dataset. The dataset is a healthcare dataset. I've downloaded it from Kaggle. It has several factors: hypertension, heart disease, body mass index, whether the person has a sedentary lifestyle or not. All these factors are present in the dataset, as well as a column which says the person has actually suffered a stroke or not. The column contains binary values 0 or 1. 0 stands for the person did not have a stroke, 1 stands for the person has had a stroke. This dataset has got another severe problem, which is it is extremely biased towards patients who did not have a stroke. Like, the distribution is very uneven. Like, there are multiple entries where the person did not have a stroke and very few entries where the person actually had a stroke. This can create problems when training the model, because let's just say for every case our model says that the person did not suffer from a stroke, it will be correct in numerous cases, but that is not what the point of the experiment is. So this needs to be addressed. Now, this, as you can see, that the data set distribution is quite uneven. So now we'll move on to the type of machine learning model which has been used. The machine learning model that we have chosen for our use case is logistic regression. The reason for choosing logistic regression, it's a supervised learning algorithm. Like, the data set has got labels in it, whether the person has suffered a stroke or whether the person has not suffered a stroke. So the reason of choosing logistic regression is pretty simple. Let's say we have the data set. There are several independent variables. Let's say this represents the BMI, this represents whether the person has heart disease or not, this represents if the person has sedentary lifestyle or not. And another line, these are actually people who have suffered from a stroke, value of 1, this is value of 0. Now these data points represent their values in respective cases. Now what we are trying to do is we are trying to establish a relationship, in the sense that we want to do a binary classification based on these several factors. Like, there will be a decision boundary. Now, these independent factors, this function is called the sigmoid function. These independent factors, sigmoid function can essentially squash these independent factors into one variable, which, and we will attempt to classify that variable. Let's say the value of that variable is coming out to be 0.79. The logistic regression will have a decision boundary. Let's say it's by default it's 0.5. Now this falls above the value of 0.5, so we can classify that this person will suffer from a stroke. this is the reason that it lets us study how these independent factors actually affect the outcome. This is the reason behind us choosing logistic regression as our model of choice. And this by using the sigmoid function, we can actually predict what class the person falls in. Now, we'll move on to the next. Now, the reason for choosing logistic regression, it's pretty simple. Logistic regression actually tells you, based on several factors, that we are fitting an S-shaped curve for binary classification. The curve is obtained by the sigmoid function or the logistic function. It tells you basis on several factors like, let's say, weight, age, body mass index of the person, whether the person will suffer from stroke or not. It gives you a probability whether the person will suffer from stroke or not. By default, the threshold is set at 0.5. However, via trial and error, I have seen that the best results come when the threshold is set at 0.59. So here we are setting a threshold of 0.59. Logistic regression actually helps us understand how these factors contribute towards whether the person will suffer a stroke or not. There's also an important thing to consider here. We need to not consider factors that might not affect our dataset. We do it by something called as Wald's test. Now, we will move on to the data analysis. One of the things about the dataset was there were several missing values for the BMI column. Now, that is an integral column for my data analysis. So the approach that I've taken is I have replaced the missing values via the median value. The other thing is there was a lot of categorical data in it. Categorical data actually made it much more difficult for the machine learning algorithm to study and make accurate predictions. So I have used one hot encoding. It's basically, let's say it says obesity something, obesity has a value, is whether the person is male or female, gender of the person. It's like converting them into columns like is male, is female. Someone who is male will have is male will be 1, is female will be 0, like that. It makes the learning of the algorithm much more easier. Now, the unbalanced data set that had to be tackled, that was tackled by synthetic minority oversampling technique, which is called SMOT. And this actually helped the machine learning. This generated synthetic copies of the dataset, made the dataset much more balanced. By using a balanced dataset, we were able to make much more accurate predictions than by using an unbalanced dataset. So these were my results. This is the confusion matrix. True negatives were 792, like the model correctly predicted 792 instances where the person did not have a stroke. True positives were 37. Now, out of a total of 50 people who had a stroke, the model was able to predict 37 people of them. It's a 70%, 78% accuracy. It's a good accuracy. But the model falls short somewhere, which is this. It predicts false negatives, like 190 false negatives. It's 190 people who did not have a stroke, but my model predicted that they did have a stroke. We could potentially lower decision boundary or higher, make it higher and try it in many other ways, but trial and error, I've seen that this is the best way the model can perform. Now, there is definitely room for improvement because maybe logistic regression does not capture the relationship between all these factors perfectly. So there is definitely room for improvement in this model. Now, for my conclusion, I would say that logistic regression does definitely do a good job in catching people who could suffer from a stroke potentially. It does a remarkable job of getting all those variables and actually making a binary prediction based on those variables. Now, we could also use other supervised algorithms such as XGBoost or random forest, but just by using these algorithms, they did not yield better results. However, I do intend to pursue this topic in the future, maybe in my final year project, so that we can actually make a machine learning model or even do further research on it so that it can increase the accuracy of the model more as well as decrease the number of false positives. Here the main agenda, the main motive should be decreasing the number of false positive as well as increasing the number of true positives, that is decreasing false alarms and catching everybody who might suffer from a stroke in the future. The limitations of the data set were, the initial limitation was it's a high imbalance data set. Like, the data set was imbalanced in the sense it did not have much entries of where the person did not suffer from a stroke. Also, there was a lot of, the model was very good at sniffing out people who could suffer from a stroke, but it was also giving a lot of false positives. Now, one of the things is one of the trade-offs is we could higher or lower the decision boundary. If we lower the decision boundary further, the model will comfortably catch more people who will suffer from a stroke, but simultaneously, the number of false positives will increase. So there is a significant trade-off here. So one of the things that I did was I tried out different threshold values and saw which one gave the best results in all sense. So this is how I came with the conclusion of setting the threshold at 0.59. So this was all. Thank you. Thank you very much. Bye.